I will present today the code's update of our current clock products. I have to say I will present the work which is a combined effort for all our groups. So I will not only present work which I have done, but it was done by the whole group and effort. Before I want to go, I think. Okay. I had a different in mind sort. I will first, before I want to start, I will give you a short introduction of the evolution of our clock products. I want to show how have the clocks changed since the last 5-6 years at Code. And then I will go further into detail. What have we updated in our final clock products, which we have used the switch from the IGB08 to the IGS14. We used this step to actually create an updated clock product. Then in the second part, I want to present also what are the current works which we are doing now, the multi-GNSS clock product, what is the current status there, and what are we working on. Now I come to evolution of our clock products. First, I want to give an overview of the Clock Rapid product. Since a long time, we were running our Clock Rapid products, which were GPS-only products, and having 30-second densifications. In 2011, we started an internal product to create an R-clock GNSS process, that's how we named it, which was producing GPS and GLONASS clocks, also with 30-second densifications. And then we decided in 2015 to switch our IGS contributions from the GPS only to change to the GPS GLONASS combined product. So we stopped our old Clock Rapid product, and then we are submitting a GPS GLONASS product. Similar is now happening now with our Clock Final products. For a long time, we had our Clock Final product, which includes not only 30 seconds, but also 5 seconds densification clocks. And around in 2015, with the project XM, which came up at our institute, we did a reprocessing effort where we basically took our Clock Final and we combined it with our R-clock GNSS procedure. So we were able to actually create a final clock product which includes GPS and GLONASS, including 5 seconds densification also for GLONASS clocks. During this reprocessing, basically data was processed until I think it was mid-15. And then with the switch from the IGB08 to the IGS14, we decided to take this reprocessing routine and use this then for a new clock product, which includes the combined GPS GLONASS clocks. Additionally, until then, we were using usually 3 clusters for estimating the satellite clocks and then combine them. We decided to switch from this clustering of the stations to have one huge cluster and then invert the whole solution to get the full set of the satellite clocks. In addition, we also have parallel running, also since 2011, our MGEX clock product, which is including the 5 systems. Until now, we have the 5-minute clocks, and we are currently working on a 30-second densifications also for our MGEX product. Now I come to talk a bit more to our update of the Clock Final product. What are now our changes in our final clock? We can say we have updated our procedure with the switch to IGS14. We have extended our product to GPS and GLONASS, and we also extended the densifications for GLONASS, so right now we are submitting GLONASS 5-second clocks. We also increased the number of stations which we are processing. Before we were using 150 stations. Now with our updated scheme, we are able to process as many stations as we like. So currently we are processing more than 300 stations to create our final clock product. This is due, as I said, to the adaptive processing scheme. Additionally, we revised our bias handling. So for our kernel final clocks, we are basically using first a PPP approach to do the data screening, which are then used for the clock estimation. During the screening, or with the screening, we also estimate our biases, which are then introduced for our final clock product. This bias is basically based on the code's 30-day solution. So we take the daily biases and we align it to the 30-day average and then introduce it. Now I would like to show how this process actually works and what we have changed. Basically, we start, I see it also here, from the data screening. This comes from our PPP final. So we start already with screened data, and we already estimated the code bias. If you see here on the left side, here I see the mouse, yes. On the left side, so basically the first step we do a station-wise clock setup. So we set up for each station, we set up the normal equations, introducing the receiver and the satellite clocks, and we then immediately we pre-eliminate the receiver clocks so that we get normal equations which just include the satellite clocks for each station individually, so we can really parallelize this step and improve speed. Then we combine all these NECs, and we get a full NEC which includes all the satellite clocks, which is basically 32 GPS satellites plus the 24 GLONASS satellites times 280 clocks, as we are estimating 5-minute clocks. So we end up with more than 16,000 parameters. In order to be able to invert this whole system in an efficient way, we decided that we have to do a clever pre-elimination procedure to handle this, because if we do the full inversion on our system, it would take us over 6 hours to do it. So what we did, basically, we take the 24-hour clocks. I have to find, where is the mouse? Yes, it's here it is. So we start with the 24 hours, and then we start to divide these 24 hours into two 12-hour batches. So by pre-eliminate in each of these two batches, we pre-eliminate 12 hours. And then we have two 12-hour batches. We do the same approach again. We pre-eliminate on each of these batches 6 hours, so that we end up with 6 normal equations, which just includes 6 hours of clocks. Then we invert these normal equations, so we get basically 4 6-hour clock satellites, and then we combine them to a full solution. With this method, basically, we don't lose any information. We have also made tests. We get the same results as if we would invert the whole system in one go. The benefit is that now we are finished after 2 hours, and it's feasible for doing this on a daily processing for our final products. After we have done that, then we also have to retrieve the receiver clocks, as we have pre-eliminated them in the first part. So we start again with station-wise processing, where now we still have the code biases on the left side. But as we now already have estimated satellite clocks, we can introduce the satellite clocks and estimate the receiver clocks for each station individually, and make a parallelization, then combine them together to have one file with a set of all receiver clocks, and combine them then with the next 5-minute clocks. And let's see if I can close that. You don't see it here. And then we get our 5-minute GPS GLONASS clocks. The next step is then, as previously, as we already running before, we do then a phase-based interpolation of our clocks. So we take our 5-minute clocks, we do a 30 seconds interpolation on the we get the 30 seconds data, and then in the next step we make the next interpolation from there, so that we actually can produce the 5-second data, which we then provide. This was all I wanted actually to show from our scheme. Then here I have 2 quick plots to show you what is the impact, what is the quality of our clocks. So we're also interested in how do we fit within the ACC combination. And here we have a plot of the ACC Statistics. We see here the blue line is the switch from the IGB08 to IGS14, where we also switched our clock products. As we can see here on the upper, we see here the clock RMS is the red line. It's the code RMS. And we see here that since the switch, we have a small drop on the RMS. The same is valid for the standard deviation. And also in the next plot, this is now the standard deviations of the satellites on the above and the stations on the lower plot. Then we see a slight increase or decreasing of the RMS, which is also what we expected, as we are using now like almost a double amount of stations, so we can reduce actually the RMS of our product. With this, I would like to end the update of our multi-GNSS clock products. And I would like to continue with the multi-GNSS products. What is the current stage there, or what we are working on? Currently, we are under the revision of our clock clustering. At the moment, we have 3 GLONASS, GPS, and Galileo clusters, with each 4 stations. And then we have 2 additional clusters, including Beidou and GPS, and 1 cluster QZSS and GPS. We have these additional clusters is due to the availability of stations which are delivering the corresponding data. Especially, we want to have, as possible, a global distribution of the station, but for QZSS, we have then basically all stations which have QZSS in the individual cluster, to really have the most stations contributing for this clock. The second part which we are working on is the phase-based clock interpolation. So we would like to offer in the future, or in the near future, 30-second clocks. And the last part we are also working on is on the revision of the code bias handling for our clock estimation. At the moment I want to show why we are currently working on the revision of the clock. Our colleagues at SwissTopo, which are doing MGEX solutions operationally, they did some analysis for our MGEX products. And we see here in this big table, we see here the MGEX solution, which they're basically, we see here the kinematic solution, the RMS of a 3-day kinematic solution compared to a 3-day static solution. And we see on the right side basically the RMS of this kinematic solution. We see here, if you look at the up component, that of course, if we start with the MGEX and we're just using GPS and GLONASS, that we have here a repeatability of roughly 11.4 millimeters, and the more system we add, the better we get, or the lower the RMS get. If we compare it to the solution which we have from our official code product, from the final product we see on the lower line, with the green one, we see here that we have for the GPS GLONASS a lower RMS than for the MGEX. And to analyze what is actually the cause why we have a little bit higher RMS, there was an additional experiment done that we have actually used the clocks which are just coming out from the combination of the GPS, GLONASS, and Galileo without using the Beidou and QZSS. And we see here by using just the GPS, GLONASS, and Galileo that we actually achieve a better repeatability. And for this we're now looking for the cause. And one possible problem could be that we have some different receiver clocks for the individual receivers. Here we have a station with quite a good behavior. What we see here, basically, we see on the right corner, we see the clocks from a GPS only or GLONASS only solution. So we really have the GPS clock, the GLONASS clocks, and so on, which is then compared to the combined clocks. And we would like to have basically no offset between these clocks. If we look, then we see that we have from some station really some different behavior, especially for this here, for this station. We see that the clocks for the Beidou, that we have here some kind of offset and some jumps within the time stream. And we are now looking currently into this to see how we can handle this and improve our clock product. And on this we're currently working on. The next part is I want to show a quick demonstration, already test we have done for our phase-based interpolation for the 30 seconds. We see here a PPP solution for the station SIM3. We have here the red one line is the ANRT, so it's a solution for manual real-time, the double difference solution compared to the PPP solution using the 30-second densification. And we see that we get a quite decent result. So this looks quite promising. From the bias handling, we can say we have, since the 16th of June, we're using a 30-day mean MGEX bias set for our products. Then we are only using biases at the moment which comes from the ionosphere-free linear combination. And the combination is the normal equation level. We are currently we also have ready a prototype available for ionosphere estimation using the 5 systems. This is still a prototype, so we're working on that. And of course, then we're also working on the combination from both sides, from the ionosphere and the geometry-free linear combination biases to make a combined product. And with this, I come to the final slide, to the conclusion. Basically, we have now a full inversion of the satellite without clustering for the clocks. We have a mathematically correct situation. We could reduce the 6 hours. By inversion, it's now done by 6 hours bins. And we get a nice results. For the MGEX, we can say the clustering scheme is currently under revision. The 30-second interpolation is coming. And for the bias products, for the clocks which are using now a 30-day average. And with this, I would like to come to end for my talk.